You can have two objects at the same temperature, but one holds way more energy. Why? The goal of the video is to understand the meaning of internal energy, which is different from heat and temperature, and why it's so misunderstood in physics. Internal energy is the total microscopic energy stored inside of a substance. So this includes the kinetic energy of all the moving particles that are bouncing around inside. In real life systems, it also includes potential energy from vibration, bonds, and rotation. Gases, we keep it simple. It's just the total kinetic energy of the molecules. And this is why internal energy is not the same as heat. Heat is energy in motion, energy being transferred between objects. Internal energy is energy that's already stored inside a system. And this is why internal energy is not equal to temperature. Temperature tells you the average energy per particle. Internal energy tells you the total energy across all particles. You can have two things of the same temperature, for example, a cup of coffee and a swimming pool. They can both be at, let's say, 25 degrees, but the swimming pool holds way more internal energy. Here's an equation. It's the equation for ideal gases, which is internal energy, U, equals 3/2 nRT. This might remind you of the ideal gas law. N is the number of moles. R is the gas constant, which is something like that. And T is the temperature given in Kelvin. This only applies to monatomic ideal gases, like helium or neon. What does that mean? A monatomic gas, new word for you, it means a gas with one atom. Mono atom. So this equation shows that internal energy only depends on two things: how many gas particles you have and how hot they are. The others are constants. Why this matters is that heat can raise internal temperature. But work, if you remember from work and energy, work can raise internal energy as well. So internal energy will determine how much a system can do. It's like the fuel in the tank. Internal energy is what's already there. Heat is what flows in, and temperature is just a gauge. It's invisible, but it's what drives everything. Phase changes, pressure changes, energy balances.